Hello all. Welcome to the series of solid principles. In this video, we are going to learn about the fourth solid principle, which is called interface segregation principle. Let's look at what the principle says. It goes like this. No client should be forced to depend on methods it does not use. Let's understand this with the help of an example. Let's say you have an interface that represents peripheral devices. We have multiple methods in this interface for different purposes such as printing, scanning, and fax-related functions. Now, let's see the classes that represent individual peripheral devices and implements this common interface. We have a class that represents Xerox machine, whose functionality is to only print and scan. However, since this class implements the device's interface, it has to implement all the methods present in the interface. Therefore, the fax-related methods will have blank implementation. Similarly, let's say you have another class called printer, whose only functionality is to print. However, this class also has to implement all methods present in the interface, leading to blank implementation of scanning and fax-related methods. Now, suppose you have to provide these classes as a packaged library for other clients to use. When any of the client tries to use a printer, the client as a developer does not need look into the class methods implementation and tries to call unimplemented methods thinking that the functionality is supported by the class. This will lead to code breaks, and the library won't be reliable for the client. Therefore, unimplemented methods are almost always indicative of a poor design. This goes against the interface segregation principle, which says that no client should be forced to depend on methods it does not use. So, how do we fix this? The easiest way to fix this is to split the big interface into smaller interfaces. So, let's take the generic interface called devices and split it into three interfaces: print, scan, and fax interfaces. Print interface will contain only printing-related methods, scan interface will contain only scanning-related methods, and fax interface will contain the fax-related methods. Now, let's change the classes too accordingly. The Xerox machine class has both printing and scanning functionality. Therefore, it will implement both print and scan interface in order to use both functionality. Note that it does not have to implement the fax interface, as it does not require fax-related functionality. Similarly, the printer class only needs to implement print interface. If there is any other class, say fax and scan machine, that scans and fax the documents, then this class will implement both fax and scan interface. You can see that the classes have become much cleaner now, and there is no more blank implementations of methods. So, we have solved the problem by segregating the interfaces. This is one way of following the interface segregation principle. Now, if you feel that there are certain methods that are common between a printer, scanner, and a fax machine, you can have a parent interface with the common methods. And you can have the print, scan, and fax interfaces extend the parent interface, adding specific methods. This was about interface segregation principle. In the next video, we will wrap up this principle by seeing various methods to identify where this principle is being violated in any software design. Thank you for watching. Please subscribe for more such content.